Hello everyone, welcome to another Quad Education Test Prep Fundamentals video. My name is Tom, and today we're talking about an esoteric little triangles problem that comes from the math sections of the ACT and sometimes the SAT. It's one of those problems that I feel like is a really good microcosm for how the test combines what's pretty simple material with some pretty tricky questions. So let's take a look. Okay, so first of all, I realized I used the words esoteric and microcosm in the intro there, and I guess I'm just that much of an SAT, ACT tutor because that's the way that I talk in real life. But if you're wondering, esoteric means very specific to a certain situation and not applicable to other places, and a microcosm is an instance where we have something that is a small example of the whole, which really illustrates the whole well in that small example. So the topic today is areas of rotated triangles and coordinate planes, which is also a really good illustration of the fact that it sounds complicated but really isn't, which is very much also a microcosm of the SAT and ACT, things that are simple but obscured in tricky ways. So our review today is pretty basic, which is just to say that the area of a triangle is 1/2 base times height. I think we all knew that. And if not, we're just reviewing from a long time ago. So area of a triangle, 1/2 base times height. Keep that in mind. There are other ways to calculate the area of the triangle, such as 1/2 AB sine, which is to say the AB are the adjacents to an angle and the C is the angle. And suffice to say, we're not going to use this one today. And if you're in a question sort of like what we're about to look at and you're sort of spinning your wheels on the test and being a little bit concerned about the time you're taking on the question, don't do trigonometry to these and don't do this specific equation because it's still just this, but it's sort of hidden. So what do I mean by that? Well, let's just talk for a second about 1/2 base times height. So, if we have a triangle that's like very generic, we basically say that here is our height. It makes lots of sense. It's inside of the triangle. But it doesn't have to be. So this point right here, the highest point to the lowest point is the base. And the highest point doesn't necessarily need to be on top of the base. It could be something like this, where the point is outside of it, but the height is still the same, perpendicular to the base. It just happens to be outside of where the base is now. And so the areas of these triangles, given that they have a base here and a height here, even though they look very different, they have the same area. And another thing to think about is the base and the height are always perpendicular to one another. So even if the base looks like this, or even like this, the height is still just whatever is at right angles to that base. So we keep that in mind as we start to see the test put triangles within coordinate planes in different rotations. And we keep in mind the whole while, and keep harping on this, the area of a triangle is 1/2 base times height. And so with that piece of knowledge, I'm going to go ahead and say, see what you can do with these example problems. See if this makes any sense, or if you're stumped by these, in the way that I see a lot of really, really good ACT and SAT students get stumped. All right, let's take a look. So looking at the question here, the vertices of triangle ABC are given in the standard coordinate plane above, which of the following is the area of the triangle? And they tell us where A, B, and C are. And, maybe we start thinking about, oh man, there's an angle here. We don't have these angles. How are we supposed to get them? Or we want this length of side right here. We're going to use distance formula, or about this one. And then we maybe stumble across the fact that we know how long this is right here. We know that this is going from the point 8.2 to the point 8.9, so that's 7. And then we sort of in our minds realize that we can rotate this. There's something that looks sort of like this, where we have a base of 7. And then we think to ourselves, well, what's the height? Well, fortunately, we know that this right here is parallel to the y-axis, so that means that perpendicular to that must be the x-axis, which is to say that this way must be our height. So that's to say the line parallel to the endpoint of point C, must be perpendicular to the line parallel to A and B, which is to say the distance from this x value to this x value is going to be our height. And 8 minus -4 is 12. So we have a base, we have a height, we can calculate an area. Area equals 1/2 base times height, 1/2 of 7 times 12, which is just to say 7 times 6, which is 42. So really big fan of that question. Very tricky. All right, next practice problem here. See how you do with this one. All right, let's take a look. So question asks, which of the following expressions represents the area of DEF shown in the standard XY coordinate plane above. And so we have all these really convoluted values here. And you can spin your wheels and you can look at these for a really long time until you realize that, once again, the area of a triangle is 1/2 base times height. So can we find the base? Well, apparently we have letters. And that's to say that the distance from here to here, well, that's the base. And we know that the distance from C to A is whatever the difference between those 2 points is. So it's whatever the distance between C and A is. So if something like C was like 4 and this was like -3, then the distance would be 4 minus -3, which is 7. And then we do the same thing for the height, which is to say we go from D up to the height up here, which is E. So that's just going to be, the height is going to be D minus E, or rather the other way around, E minus D. As long as we're being careful with our signs, it's not really going to matter, but just to be specific here. So if C minus A is our base and E minus D is our height, and we just basically put that into our equation and get C minus A times E minus D. And we see that the answer is A. So really great example of how to underthink a question and get a really available answer. You can get wrapped up in what even the heck they're trying to say here with E and F and spend way too much time on this problem, or you can just remember area equals 1/2 base times height and get through it pretty quickly. Okay, that's it for this video. Remember, if you see a triangle in a coordinate plane, it's probably still just your old 3rd grade area of a triangle equals 1/2 base times height equation, just sort of hidden in there in such a way that it looks like it's intimidating, but really it's not. So if you found this material useful, we hope that you will like and share the video and subscribe to Quad Education. If you require any kind of tutoring, please let us know. Thank you for watching, and I hope you have a great day.